Section 1.8 is on interpreting graphs of functions. In this section, we're going to go over a lot of vocabulary terms and how they apply to graphs of functions. The first one is the intercepts, and that sounds a lot like the word intersect, and it kind of means the same thing. The intercepts are the points where the graph intersects an axis. Where does it cross either the x or the y axis? The x-intercept is the x-coordinate of the point at which the graph crosses the x-axis. So what is the x when it's crossing the x-axis? And at this point, the y-coordinate is always 0. The y-intercept is the y-coordinate of the point at which the graph intersects the y-axis. What is the y when the graph crosses the y-axis? And at this point, the x-coordinate is always going to be 0. Let's take a look at an example of a graph here. So here I have a pink line, and it is crossing the y-axis right here at the point 0, -2, and it's crossing the x-axis right here at the point 4, 0. So for the x-intercept, we're going to take a look at the x-axis. It crosses it right here. The point is 4, so my x-intercept is 4. Right here, it crosses the y-axis. My y-coordinate is -2, so the y-intercept is -2. Notice, as I said above, for the x-intercept, the y is 0. For the y-intercept, the x is 0. Let's take a look at this example. This graph shows the temperature, which is y, that's going to be on my y-axis, of a medical sample thawed at a controlled rate. So in other words, something was taken out of the freezer and is being thawed at a controlled rate. Identify the function as linear or nonlinear. Well, that's pretty easy. That's linear because it's a line. Okay? And then estimate and interpret the intercepts. Okay, so let's start with the x-intercept, and that would be this point right here where that crosses the x-axis. Okay, so my x-intercept is going to be whatever the x-coordinate is right there. And notice the markings on the x-axis, so that would be my x-intercept would be 1. Now, what does that mean? Interpret it means describe what's going on there. Well, when x is 1, that means the time is 1 hour, or 1 hour since the sample was taken out of the freezer. Okay, so 1 hour after it was taken out of the freezer, what's its temperature? Well, notice that at that point, the y is 0, so the temperature is going to be 0 degrees Celsius. Okay, so 1 hour after being removed from the freezer, the temperature is 0 degrees Celsius. Okay, so 1 hour after this was taken out of the freezer, its temperature is 0. At this point right here, that's going to be my y-intercept. And at that point, my y value is going to be -5. Notice that the y-axis is actually marked a little bit differently. Every 2 boxes is 10, so 1 box is going to be 5. So my y-intercept is -5. Now let's see what that means. So on the y-axis, when it's -5, that means the temperature is going to be -5 degrees Celsius. My x-coordinate at that point is 0. So that was when his time is 0. That means that when the sample was taken out of the freezer, okay, its temperature was -5 degrees Celsius. So when the sample was removed from freezer, temperature is -5 degrees Celsius. Okay, because at that point time is 0 and the temperature is -5. And actually, I just want to make a comment about this graph. It's actually kind of silly that it kind of goes this way, because we don't usually talk about negative time. So I actually wouldn't pay too much attention to that part of the graph right there. Okay, here's a little more vocabulary. Line symmetry is a feature of a graph that is reflected over a vertical line. So if you have a vertical line, and if you can fold the graph on that line, and the one side is the same as the other side, then we say it has line symmetry. So here I have something that looks like a parabola, and I have this vertical dashed line here, and if I could fold this screen across that dashed line, the right part of the curve would be right on top of the left part of the curve. So yes, that has line symmetry. Here my black line, if I were to fold it on the blue dashed line, it would not be on top of it. This part would not be exactly on top of that. So this has no line symmetry. And here's a whole bunch of vocabulary about functions, and we'll take a look at these in more detail in a chart and in an example. We say that a function is positive where its graph is above the x-axis. We say that a function is negative where the graph is below the x-axis. A function is increasing wherever it goes up as you go from left to right. A function is decreasing wherever the graph goes down as you go from left to right. Extrema are relative high or low points in the graph, and we have two of those. We have a relative minimum, which would be the lowest point in a region. It may not be the overall lowest point, but just in a region it is. A relative maximum is the highest point in a region. And then the last thing we're going to take a look at is end behavior, and that's basically what y is doing as x increases and as x decreases. Here's a cool chart from your textbook which goes over all of these with some pictures, and I'll talk about it briefly here. Remember, it's positive when it's above the x-axis. So for the first one here, the blue parts are where the function is positive, and it's negative where it's below the x-axis, so the red parts here are where the function would be negative. A function is increasing when it's going up, and this blue section right here is the interval on which it is increasing, and right here is where it is decreasing. And it's a little confusing because we have an arrow going this way, but remember, you're viewing it from left to right. So as I'm going from left to right, it's going down, and then right here it starts going up, and then right here it starts going down again. So that part would also be decreasing. Remember, your extrema are your relative high or low points. Right here at point A, we would have a relative minimum because that's a lower point. And right here at point B, we'd have a relative maximum. Excuse me, because that's a relative high point. And then end behavior is basically what's going on at the arrows here. So as my x is getting smaller, my f of x, or my y, is getting bigger. And as I go in this direction, as my x is getting bigger, my y, or my f of x, is getting smaller. So let's take a look at one example here where we have to do about 12 different things to it. We have to identify this as linear or nonlinear, and then estimate and interpret the intercepts of the graph, see if there's any line symmetry, tell where the function is positive, negative, increasing, and decreasing, the x-coordinates of any relative extrema, and the end behavior. Okay, so there's a whole lot going on with this graph. So let's start with the first one. The function, is it linear or nonlinear? This one, even though it's made up of straight lines, it is not like one line altogether. So it is nonlinear. Nonlinear would be just one straight line. Interpret any intercepts of the graph. So let's see. So do we have some x-intercepts? We would have an x-intercept. I'm going to go ahead and put a pink dot here. We would have an x-intercept right about here, and one right about there, and actually also right here. Okay. So I'm going to have x-intercepts. What are the x's of those points? 0. And that's probably about 3.2. And that's probably about I'll call it about 4.6. Okay. So now, what do those mean? Well, let's go ahead and find the y-intercepts, and then we'll talk about what each of them mean. A y-intercept would also be right here. And actually, that's my only one. That's the only place it crosses the y-axis. Oops, hold on. Let me get some purple here. So I have one y-intercept at 0. Okay, so what do my x-intercepts mean? So the title of this graph is stock value, and you'll notice that my horizontal axis here, my x-axis, is the time since the opening bell. So And my vertical axis here is the price variation in points. So in other words, what's happening right here at 0, 0 is the stock market hasn't opened yet and the price hasn't changed. In other words, it's the original price when the market opened. Okay? So at 0 right here, actually at point, I'm going to go ahead and call that 0, 0. At 0, 0, the market hasn't opened. And the price hasn't changed. Because once the stock market opens, then the prices go up and down. Okay? And at these other 2 points here, okay, so this point right here at 3.2, that means 3.2 hours after the market opened, my price is back to its original price. Okay? So at 3.2, I'll go ahead and put those together. At 3.2 and about 4.6 hours after opening, I'm back to my original price. So you'll see that before that, the price went up, and then the price went down, and then it came to its original price, and then the price continued to go down and came back up, hit its original price again, and then continue to increase. So those are my intercepts. Do I have any symmetry? Can I draw a line such that I would fold it? No, there's no symmetry. Okay, now where is the function positive? Where is the function positive? It's wherever it's going to be above the x-axis. So it's positive between x equals 0 and x equals 3.2. And that's this area right here, just this part right here. And then it's also positive when x is greater than 4.6. And x is greater than 4.6. That's not a very good greater than sign. 4.6. Okay? My graph is negative when it's below the x-axis, and that's just going to be just this region right here, and that's going to be between x equals 3.2 and x equals 4.6. That's just this little part down here. Where is the graph increasing? So where is it going up? On this segment right here, okay, between x equals 0 and x equals 2. And it's also going up, even though this part right here is below the x-axis, it is going up on that interval. And between, and when, actually it doesn't end, it keeps going here, when x is greater than 4. Okay. Where is it decreasing? In other words, where is it going down? And that would be just on this interval right here where it's going down. Between x equals 2 and x equals 4. And then do we have any, the x-coordinates of any extrema? So right here, I'll go ahead and mark these in color. Right here, we have a relative max. And right here, we have a relative min. Okay, so I have a relative max at, they want the x-coordinate of that, at x equals 2. And then down here at the green point, I have a relative minimum, at x equals 4. And now we need to talk about some end behavior. Okay, and again, I think the graph is a little bit confusing. I really don't like the fact that they put an arrow here, because that kind of indicates that time would be going backwards, that we could have negative time. So I'm really going to only focus on what's going on right here. at this arrow right here. I'm going to erase that. Okay? So at that point, where the circle is, my x is increasing and my y is increasing. So as x increases, in other words, as x gets bigger, my y is increasing. Okay, and what does that mean? That means that as time goes on, the stock is increasing in value. As time goes on, my stock is increasing in value. Okay. So in this section, we saw a whole lot of vocabulary. And the homework, the problems you're going to be working on in class are going to be a lot like these, where you have to do all of this different stuff. I would refer back to that chart in the textbook. I think it gives a really clear example of and marking up the graph of what each of these concepts means.